Welcome my friends. In this video, we will practice converting from rectangular to polar coordinates and from polar to rectangular coordinates, specifically in the context of equations. Recall that there are two common ways to identify a point. Using rectangular coordinates, we specify the distance you must travel in the x direction, or horizontal direction, and the distance that you must travel in the vertical, or y direction, in order to reach the point. In polar coordinates, you specify the angle that you must travel from the positive x-axis measured counterclockwise to reach the point. And then you specify the radius, or distance, from the pole, which is the same thing as the origin, that you must travel in order to reach the point. In my previous video, I derived all of these equations. If you have rectangular coordinates and you would like to convert to polar coordinates, that means you have x and y and need r and theta. To find r, you can just take the square root of x squared plus y squared. And to find theta, you can just take the inverse tangent of y over x. If you already have polar coordinates and would like to convert to rectangular coordinates, then that means that you already have r and theta and would like to change to x and y. X is equal to r times the cosine of theta, and y is equal to r times the sine of theta. In this video, we will specifically look at converting between rectangular and polar coordinates, or vice versa, in the context of equations. Let's take a look at a problem. We are asked to convert the equation r is equal to 2 to rectangular form. That means instead of having r in our equation, we would like to have x's and y's. We know that r is equal to the square root of x squared plus y squared. So instead of having r is equal to 2, we could change r to the square root of x squared plus y squared. We will have the square root of x squared plus y squared is equal to 2. Now technically, at this stage, we have converted to rectangular form, but we might want to simplify this a little bit. If we square both sides, we will clear the square root, so that we will have x squared plus y squared is equal to 4. Now you might recognize this as the equation of a circle. We could plot this onto a polar coordinate graph. There are a few different ways to think about how to graph this. One way is to look at the polar form equation. We are told that r is equal to 2. Theta is not specified. We are only told that the radius is equal to 2. So that means that the angle theta could be anything. So anywhere on the graph with a radius of 2 would be consistent with our equation. This is what we have. We have a circle centered at the pole, which is another name for the origin when you're talking about polar coordinates, that has a radius of 2. The other way to think about this is in the rectangular form coordinates. X squared plus y squared is equal to r squared is the general form of the equation of a circle. The 4 here is r squared. So r is equal to 2, which we already knew based on the polar form equation. This is a circle centered at the origin with a radius of 2, which is exactly what we have already graphed. Let's try another one. We are asked to convert the equation r cosine theta is equal to 4 into rectangular form. That means instead of having r's and thetas, we would like to have x's and y's. If you look back at the equations that I listed on the first slide, you'll see that we have x is equal to r times the cosine of theta. We have r times the cosine of theta in our problem, so we can just substitute that with x. So instead of r times the cosine of theta is equal to 4, we have x is equal to 4, because x is equal to r times the cosine of theta. Let's graph this. X equals 4 is a vertical line at x equals 4. This is what that would look like. R cosine theta is equal to 4 is the same thing as x is equal to 4, which is a vertical line at x is equal to 4. Let's try this one. We are asked to convert the equation theta is equal to pi over 4 into rectangular form. We know that theta is equal to the inverse tangent of y over x. The form of this equation before we took the inverse of both sides was that tangent of theta is equal to y over x. We can use this to help us solve this problem. If theta is equal to pi over 4, we can take the tangent of both sides. We will get tangent of theta is equal to tangent of pi over 4. But tangent of theta is the same thing as y over x, so we can substitute y over x in for tangent of theta. We will get y over x on the left-hand side. On the right-hand side, we are asked to evaluate tangent of pi over 4. Tangent is sine over cosine, and at pi over 4, sine and cosine are the same. They are both the square root of 2 over 2. If sine and cosine are the same, then that means tangent must be equal to 1. So tangent of pi over 4 is equal to 1. Perhaps we would like to solve this for y. Let's multiply both sides by x. The x's will cancel on the left-hand side, and we will get y is equal to x. We could graph this on a polar coordinate graph. There are a few different ways to think about how to graph this. One way is to think about the polar form. We are told that theta is equal to pi over 4, but we are not told the radius. There is no r in this equation. That means that r could be anything. All we know is that we have an angle of pi over 4. This is going to create a straight line at pi over 4 that looks something like this. You could also think of this as y equals x. Y equals x is a 45-degree line, which is exactly what we have here. Let's try one going the other way around. We have x is equal to -2, which we would like to convert to polar form. Once we convert to polar form, we are asked to solve the equation for r. We know that x is equal to r times cosine of theta, so we can substitute x for r cosine theta in our problem. We have x is equal to -2, which is the same thing as r times the cosine of theta is equal to -2. At this point, we have converted the equation to polar form. Instead of having x's and y's, or in this case just x's, we have r's and thetas. Now we can solve the equation for r. If we divide both sides by the cosine of theta, we will get the cosines to cancel, so that we have r is equal to -2 over cosine of theta. Now technically this is correct, but perhaps to clean this up a bit, we know that cosine of theta and secant of theta are reciprocals, so this can become r is equal to -2 times the secant of theta. What does this look like on the graph? Well, hopefully you know that x is equal to a constant is just a vertical line, just like we had a few problems ago. So this is going to be a vertical line at x is equal to -2. Let's try this problem. We are asked to convert the equation y is equal to -x into polar form. Then we are asked to solve the equation for theta. Well, we have y's and x's in our problem, and we know that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So if we would like to be in polar form, we can make each of these substitutions into our problem. The y will become r sine of theta, and the x will become r cosine of theta. We have r's on both sides of our equation, so we can divide by r to cancel them. That will leave us with sine of theta is equal to negative cosine of theta. Now it might be a little bit unclear what you should do next. There are a few different approaches. One way would be to just think of some angle where sine and cosine are the same except for cosine would be negative. Well, we know that sine and cosine have opposite signs in either quadrant 2 or quadrant 4. In quadrant 2, sine would be positive and cosine would be negative, and in quadrant 4, cosine would be positive and sine would be negative. We also know that at pi over 4, sine and cosine are the same. So therefore, if we have an angle in either quadrant 2 or quadrant 4 that has a reference angle of pi over 4, then that will satisfy this equation. For example, 3 pi over 4 would be the angle in quadrant 2 that would satisfy this equation. The angle in quadrant 4 would be 7 pi over 4. In either case, sine of theta or cosine of theta would give you the square root of 2 over 2, but with opposite signs, so that the negative sign will correct things, and we would have the same answer. Alternatively, if you don't like to think about it that way, you could just divide both sides by cosine, so that you can change the left-hand side to tangent. Sine over cosine is the same thing as tangent, so we get tangent of theta is equal to -1. This is basically asking us the exact same question. At what angle are sine and cosine the same but have opposite signs? Again, the answers are going to be on one revolution of the circle, either 3 pi over 4 in quadrant 2 or 7 pi over 4 in quadrant 4. For these types of problems, you don't have to solve for every single possible solution. You just have to find one. So in this case, I'm going to let theta equal 3 pi over 4. We can graph this on a polar coordinate system. Theta equals 3 pi over 4 does not specify r. We are not told what the radius is. We are just told the angle. So this is going to be a straight line along 3 pi over 4, which is right over here. So this is what this is going to look like. Theta equals 3 pi over 4 is a straight line along 3 pi over 4. Now, I just as well could have let theta equal 7 pi over 4. Theta equaling 7 pi over 4 would create the exact same line, or any angle that is coterminal with 7 pi over 4 or 3 pi over 4. We don't need to solve for every solution, we just need to choose one. So this is not a unique solution for theta, but it nonetheless is one solution that satisfies this equation. Let's try this problem. We are asked to convert the equation y is equal to the square root of 3 times x to polar form. Then we are asked to solve the equation for theta. If we would like to convert to polar form, then generally the equations we would like to use are x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. We can substitute these into our equation. Y is equal to r times the sine of theta, and x is equal to r times the cosine of theta. Since both sides include an r, we can divide both sides by r. This will cancel the r's, and we will be left with sine of theta is equal to square root 3 times the cosine of theta. If we divide both sides by the cosine of theta, we will again get tangent of theta on the left-hand side, because sine over cosine is just tangent. So we need to find one angle where tangent is equal to square root of 3. Well, if you know your unit circle, you know that tangent of pi over 3 is equal to the square root of 3. So theta equals pi over 3 is our solution. We can graph this on a polar coordinate system. Theta equals pi over 3 is a straight line on the angle pi over 3. Once again, there are more than one possible solution. We could have also said that theta was equal to 4 pi over 3, or any angle that is coterminal with pi over 3 or 4 pi over 3. Let's try another one. We are asked to convert the equation x squared plus y squared minus 3x is equal to 0 to polar form. Then we are asked to solve the equation for r. So if we want to be in polar form, we have to get rid of the x's and the y's and replace them with thetas. We know that x squared plus y squared is equal to r squared, and that x is equal to r times cosine of theta. We can replace the x squared plus y squared with r squared in our equation, and the x with r times cosine of theta. We will be left with r squared minus 3 times r cosine theta is equal to 0. Then we need to solve the equation for r. We can add 3 times r cosine theta to both sides. We will be left with r squared is equal to 3 times r cosine theta. If we divide both sides by r, one of the r's on the left-hand side will cancel, and we will have r is equal to 3 times the cosine of theta. We could graph this, but the graph is a little bit more complicated than the graphs we've looked at so far, and is beyond the scope of what we will be studying in this video. Okay, let's look at one final problem. We are asked to convert the equation x minus 5y plus 5 is equal to 0 to polar form, and then solve for r. We know that x is equal to r cosine theta, and y is equal to r sine theta. That means we can make a substitution for both x and y in our problem. Instead of x, we will have r cosine theta, and instead of negative 5y, we will have negative 5 r sine theta. Since we need to solve for r, we will want to factor an r out from both terms. We will have r times cosine of theta minus 5 sine of theta plus 5 is equal to 0. Then we can subtract 5 from both sides to get r times cosine of theta minus 5 sine of theta is equal to negative 5. Since we need to solve for r, we can divide both sides by cosine of theta minus 5 sine of theta. We will get that r is equal to negative 5 divided by cosine of theta minus 5 sine of theta. At this stage, we have finished our problem. Alright, my friends, that finishes this video related to converting from polar to rectangular equations or vice versa.